Confirmation about the audio, please. If the audio is clear and available, kindly confirm the same, guys. Thank you. Ashish, leeward side is the side of the mountain which is on the other direction of the wind motion. So, for example, if you have a mountain like this, if the wind is coming from this direction, this will be the windward side. The one facing the wind will be the windward side. The one opposite to it will be the leeward side. Thunder, Mansi, is caused, thunder and lightning basically is caused because of the impact that you see over the air in that region. So lightning is created when you have accumulation of charge in the clouds. And why is it that the charges get accumulated in the cloud? Because as the particles they rub against each other, they either gain a charge or lose a charge. So when you have such accumulation of charge, you have opposite polarity, negative and positive. There is a flow of charge between those. And that is what we observe as lightning. Whenever lightning occurs, there is a sudden heating of air in that small area. And that leads to a sudden violent expansion of air, which we hear as the rumbling of thunder. Shalu, why isotherm is cut each other? Please tell. O bar cannot. So I think your question is why isotherms and isobars cannot cross each other. Because think about it, when we talk about isobars, so they represent places indicating same pressure. When we talk about isotherms, they represent places indicating same temperature. So all the places on that isobar will have that particular temperature. So if you have a 30-degree C isobar, so all the places in this will be having 30 degrees. But if, let's suppose you have a crisscross with a 25-degree C isobar, here you have a 30-degree C isobar. So what will be the temperature at this point? Will it be 25 or will it be 30? So that is why a same point can never represent two temperature or two pressure conditions at the same point of time. So that is why they will never be crisscrossing each other. Chinook is eastward, Pradeep. And Satyam, cloud chapter is neither given in NCRT nor in Baiju's book. That is why we study it in the class, my dear friend. You will come across many such topics as we move ahead, which you won't find in these books. That is why you attend the class. That is the benefit of the live class. How Coriolis force is perpendicular to the pressure gradient force? It is a very simple concept. When we talk about pressure gradient force, what is the direction from a high pressure to a low pressure? Let's suppose it is moving in a southern hemisphere. From high pressure to low pressure, that is the direction of the pressure gradient force. So in which direction will the Coriolis force act? To the leftward of it, absolute leftward. That will be perpendicular. So for example, if you have a high pressure here, a low pressure here, direction of pressure gradient force will be like this. But the wind will not move like this. Wind will have a Coriolis effect as well. And Coriolis effect will try to bend the wind to the leftward direction. So that is why the eventual wind will be in a resultant position. So this is where you have that kind of a perpendicular angle created. Okay. How relative humidity increases with the cooling of air? Ziba, that happens because when you cool down the air, you reduce the carrying capacity. And what is relative humidity? The amount of moisture present as compared to the carrying capacity. So if the carrying capacity, which is in the denominator, if that reduces, what will happen to the overall relative humidity? It will always indicate an increase. We'll have it today, Chandrajyoti, about the map work, the homework of that. The deflection is more when the wind velocity is high. Then why Coriolis force is absent in equator? First of all, this is not related. This is not interrelated with each other, Biswajit. So, but when we talk about the region of equator, there you don't have a Coriolis force, because if you talk about, let's suppose, a wind movement which is happening from 8-degree north to 8-degree south. Now there, the rotational speed of the planet will almost be same at the region of equator, even at the region of 8-degree north, even at the region of 8-degree south. Why will the speed of rotation be the same? That is because all of them will have almost the same radius. So that is why, because the rotational speed is the same, so that is why the object moving between those will not suffer any kind of a deviation. Mansi, PYQs we have been covering almost on a daily basis. We have discussed a couple of PYQs yesterday also, day before that also. So is everyone aware that we are discussing PYQs, or are we under the perception that the PYQs are not getting discussed? Please let me know. I hope we are aware that we have been discussing the PYQs along with geography, along with geomorphology, along with the portion of atmosphere and temperature also. We discussed these PYQs. Komal, no, there is no class tomorrow. But I hope, Mansi, you understand that we basically are covering the PYQs. Sham, if high pressure and low pressure created in same latitude but in different longitude, then what is so? In that case, the Coriolis force is not very prominent. When you have in the same latitudinal motion, that is where the it is not very prominent. Okay. Why thunder and lightning? Thunder and lightning is created because of the particles rubbing against each other in the clouds, and that is when they gain or lose charge. That is where you have accumulation of charge, different charges in different areas, and you have movement of electricity or charge between them. That is what we experience as lightning. And whenever you have lightning, it has got a very high temperature, so it heats up the air immediately around it with a very high degree, and that is where the air tends to expand almost violently. So that is what gives the thunder noise. Dikshit, yes, my dear friend, Monday is a holiday. um, I was asking when we will cover the PYQs of yesterday covered topics. So, see, we are going to pick up the topics in general, which are so today, for example, we will discuss one of the PYQs which have appeared from the portion of clouds. And as we move ahead, we shall be discussing more such questions. Don't worry. We will be discussing along the way, we shall be discussing all the relevant PYQs, or if any of the PYQs we are not picking up immediately for discussion, at least I am telling you the pattern in which the questions are asked. That is much more relevant to understand. Okay, don't worry, we are discussing that. Okay, dew is basically when you have condensation on the ground surface or any particular surface, that is dew. Yes, Pratik, that is correct. So hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of climatology, where today we shall be furthering our discussion from the portion of cloud formation. Now, yesterday, we had studied about the local winds, the phenomena of the local winds. We understood that where these local winds are present, majority of them. And then we moved on into the area of the aspect of humidity and precipitation, where we understood what is humidity, what is the carrying capacity of air, and how is it that the carrying capacity does indicate a change with the change in temperature, where we observed that when an air parcel gets heated up, its carrying capacity tends to increase. It has the capability to accommodate more amount of vapor in it. And when the air is cooled down, that is when you will come across the situation where the carrying capacity of the air parcel reduces. It will be able to accommodate very little amount of water vapor present within it. Then we studied the different types in which we can express, or different methodologies in which we can express humidity. We studied what is absolute humidity, what is specific humidity, and what is relative humidity. Relative humidity is the one which is most oftentimes used in various different weather reports, in the news reportage, etc. And relative humidity basically indicates that at any point of time, at any given temperature, what is the amount of moisture which is present in the air as compared to what is the carrying capacity. Right. So that ratio is indicated by relative humidity. So when we say a relative humidity of 60%, that means the air parcel at this point of time is having only 60% of the vapor as compared to what it can overall carry. Right. Now we do know that relative humidity basically indicates a change with the change in temperature. because when you change the temperature, the carrying capacity of the air in itself changes, and that is why the relative humidity also changes. When the relative humidity reaches 100%, we refer to that as the saturation of air. That is where the air cannot accommodate any more amount of moisture or water vapor. It has got all amount of moisture that it can, right? So that is what we have seen. Now, then we observed that if you cool down the air beyond the point of saturation, condensation can happen. Now, that condensation, it can happen on the ground surface. And on the ground surface, when that condensation happens in liquid droplets, we call that as dew. If, let's suppose, the saturation point or the saturation temperature which is reached is below the freezing point, then the condensate is in the form of ice on the ground. That is what we refer to as frost. Then we observe the cloud formation, where we observe basically that as the air rises up, eventually after reaching a particular height, it obviously will lose its temperature. It will start becoming very cold, and eventually it will reach saturation. If it is rising beyond that, or if it is cooling beyond that, that is when condensates happen and condensation happens, and that is what leads to cloud formation. Now, in these clouds, you will have many of the smaller droplets and ice crystals which are there. Cloud is not a complete solid proposition out there. It is not like a solid object, right? It is composed of many of the smaller particles, regardless of whatever they appear from the ground surface. From the ground surface, when we think about the cloud, we think about it as an entity, that this cloud has got this particular shape and it can collide with the other cloud. But that is not the case. The cloud, when you think about it, its shape, its size, it keeps on varying depending upon when and where that condensation is happening. Now, these ice crystals, they slowly and steadily start becoming larger in size as more condensation happens in an area. Maybe if no more air is rising, then that size of the ice particles might not ever increase. It might remain very, very small. But when the size of the ice crystals they increase, eventually they become so heavy that they cannot be uplifted by the air anymore, and the gravitational pull of attraction actually pulls them all. And that is when these ice crystals they start falling upon the ground surface. But as they go on falling towards the ground surface, hurtling towards the ground surface, that is when they encounter a higher temperature, because the temperature near the ground surface is always high. So that is when they encounter the higher temperature, and these ice particles they melt into liquid water droplets, and that is what we receive as rainfall. Having said that, in certain areas where the ground surface temperature oftentimes is around zero or in the negative territory, for example, in high altitude places or in the places of high latitude, where the temperature really reduces quite significantly, in that case, when you have that rainfall which happens, so near the ground surface, because the air is so cold, these raindrops they refreeze into snow, very minute snow crystals, and that is when we receive snowfall. Now, we are going to study about the different types of clouds which are there. So, all in all, as you can see, there are 10 fundamental different types of clouds which are classified based upon their individual height parameters also. But broadly, if you take a look at the clouds, they have a particular name, a name which is associated with them based upon where they are found and the feature of the cloud. Now, you'll find many candidates out there who, when they start studying about the clouds, they will straight away start learning about all these different cloud types, right? All these different 10 cloud types which are there, you will find that many of the candidates, they start rectifying it immediately. That is absolutely something that I abhor. That is something I would recommend you not to do. Please don't do that. If it comes to it that you have to close your mind and mug it up, better not to mug it up. Better to leave this topic and go, but try to understand the pattern behind it. And that is more than sufficient. So the cloud types, based upon their shape, based upon their properties, they have some basic classification. For example, when we talk about the types of clouds, you have a type of cloud which is referred to as stratus. Now, what is stratus? Stratus. Now, stratus is derived from the term strata, which means layers. So, oftentimes you would observe a cloud formation which covers the sky, and you have a whitish or a light grayish kind of an appearance, which you understand that the cloud is not very thick, not very dense, but it covers a wide portion of the sky. So those kind of clouds are stratus clouds. So they basically appear in layers. Okay. They basically appear in layers. And large horizontal development is observed in these particular kind of clouds. This is one kind of a cloud type. Then you have cumulus clouds. Cumulus. It is derived from the term accumulation. So when we talk about cumulus, here, generally created due to the process of evaporation, wherever evaporation is observed, you'll find certain clouds having vertical development, like heaped up balls of cotton for that matter. So that is what is your cumulus cloud. Okay, so this was basically here the cumulus. Okay, and then you have the nimbus kind of clouds. Nimbus clouds are, the word nimbus is associated whenever you have a rain bearing cloud. Okay, the word nimbus is associated with rain bearing clouds. Then you also have another cloud type, that is cirrus. Cirrus is basically the name given to a very high altitude cloud, which can be formed at an elevation of as high as 10 kilometers, 12 kilometers from the surface. So this is generally created when the air is having low humidity, and then it rises up. Eventually, it has to rise up a great distance to reach that point of saturation and then undergo condensation. So cirrus are basically thin, high altitude clouds. They generally don't bring you rainfall. High altitude clouds. Now, with this basic parameter, you will be able to understand and name all the various different types of clouds. For example, any of the cloud type will either be in a horizontal layered format or will be in a form of a vertical development, right? That is something which is going to be the feature of this. So if such clouds are formed at very high altitude, so you will name them as cirrocumulus, because cirro and cirrus is a prefix that you attach, or simply cirrus or cirrostratus. So if at high altitude they appear in layered format, cirrostratus. If at high altitude they appear in small chunks and accumulation, cirrocumulus. Or in simply feathery wispy appearance that they appear to look like, that is what is cirrus. Then altocumulus and altostratus. So mid-level clouds, they are named as alto. So that is where, if you have cumulus type of clouds created in the mid altitude, that is at a height of 3 to 6 kilometers, generally around 5 to 6 kilometers, so there it will be altocumulus. If you have stratus clouds formed at that particular height, it will be altostratus. And then after that, we have low level clouds, which are present very close to the ground surface. And there you can have cumulus clouds, you can have stratus clouds, or you can have a combination of these two, that is stratocumulus. So when you think about the term stratocumulus, it will be somewhat like this, where it will have some property of a stratus cloud with a horizontal development, along with the property of a vertical development of a cloud as well. So this kind of a cloud type that you will find, that will be stratocumulus, where it will be a combination of both of them. This can also bring you rainfall, but not that great. Then you have certain clouds which are actually rain bearing, which will bring you very heavy rainfall. And those are the multi-layered clouds, which spread across multiple different altitudes, which spread across multiple different heights. They start from the very low level and they can extend up till mid altitude or even high altitude. So that is where you have the accumulation of all of them. That is cumulonimbus. So cumulonimbus will have very strong vertical development, and it will be very thick cloud, maybe having a thickness of even sometimes 10 kilometers or more. During the cyclonic circulation and during the cyclonic events, these cumulonimbus clouds, they have a thickness of close to around 10 kilometers or 12 kilometers sometimes. And then you have nimbostratus. Nimbostratus basically appears as large layered format having a significant amount of thickness associated. So there is a pattern to it. You don't have to learn this out. So here, this is a schematic image of it. So here you will observe the high altitude clouds. They are referred to as cirrus or cirrostratus when they appear in layered format, or cirrocumulus when they appear as accumulated system. Then the mid-altitude clouds, they are known as altostratus if they appear in horizontal format, or if they appear in chunks, altocumulus. Low level, cumulus, stratocumulus, and stratus, right? And this is your nimbostratus, where you will observe a kind of a horizontal layering. This nimbostratus within it also can contain cumulonimbus and cumulus cloud. Here in itself, inside it also, you can have vertical development of cloud, which can be observed. This will bring rainfall. And then you have cumulonimbus, the most dangerous of them all, where you observe this thickness is so very great, it can oftentimes span across multiple kilometers. Now, we had seen yesterday that thunder and lightning and these properties and phenomena will generally be observed in areas where the cloud is very, very thick. So, by taking a look at this particular schematics, can you think about that in which cloud types will you experience that thunder and lightning events? You have to understand that for them, the thickness of the cloud is a prerequisite. So, the answer is simple. Thunder and lightning will be observed either in nimbostratus or in cumulonimbus, but most of them will be observed in cumulonimbus. That is where it will be very, very common as a factor. The lightning that occurs between the clouds, that will be observed in nimbostratus also, cumulonimbus also. But cumulonimbus is the one which will have so much amount of charge that oftentimes you will have a lightning strike from the cloud to the ground also. Okay, so let us take a brief look on few of the basic cloud types. So when we talk about cirrus clouds, so how do they appear to look like? This is what the cirrus clouds appear to look like. Many of the times when you wake up early in the morning or during the day, you observe that the sky is almost clear, but then you have these kind of cloud formations which are very, very tiny in the sense that they are not very thick. They are very feathery and wispy appearance is something that you can associate with it. They get basically lighted by the solar rays before the sunrise. You observe that some portions of the sky, they start giving you a different coloration, different color hue. And then also during the time of the sunset, they will give you that coloration. Here you will find that when the sun shines, the solar rays will be able to penetrate through it very, very easily because this is not very thick. Now, these clouds, they very rarely bring you rains because majority of the times, even if let's suppose the ice crystals, they become very large and they start dropping down, before they reach the ground surface, they will re-evaporate and go back up. That is why very rarely will you come across a situation where these clouds can bring you rainfall. Okay. Now, then you have the low level clouds. So before that, the cirrus clouds, feathery, wispy formations made up of very minute ice crystals. They are often colored bright yellow or red before the sunrise and after sunset because of the refraction of light. Cirrus clouds light up long before the other clouds and fade out much later because of the solar rays getting refracted. So that is why these are very high altitude clouds, rarely bring rainfall. Right. And that is because before the crystals they start falling, before reaching the ground surface, many of the times they start to re-evaporate. And that is why no rainfall is experienced on the ground surface. Then, when we talk about these cumulus clouds, this is how they appear to look like. Observe the vertical development of these cloud layers. Now, this is again, I would repeat, it is not as if this is a solid entity having a property and a feeling of its own. If more evaporation and more condensation happens in this area, this cloud can further develop, right? This can further develop into a larger size. So the size keeps on changing. This is created or this is experienced almost in every part of the planet wherever there is the presence of a convection current, or wherever there is a presence of the process of evaporation. In those areas, you will find that the condensates, they are going to appear in smaller chunks or in certain concentrated chunks. And that is what is the feature of this cumulus. So it is a thick, low altitude cloud, usually puffy, and has got a kind of a vertical development, and they look like heaped up balls of cotton out there. It is found everywhere in the world except for the polar areas. Why? Because in the polar areas, you don't experience that evaporation anymore, right? Evaporation is observed in the other areas, but generally not across the poles. So that is why these clouds won't be found in the polar areas. Why evaporation is not observed in the polar areas? Because of extremely low temperatures, right? Then you have the stratus. Now, when you have a stratus cloud, they are basically going to spread as various different layers, right? Now, here please understand that there will be no vertical motion of the ice crystals. So that is why in this, you won't find the presence of thunder and lightning to be so prominent. And it won't bring you much amount of rainfall also. All that it can do is bring you that light rainfall, very light rainfall, where you will feel very tiny droplets falling from the sky for some duration of time. So this causes a very light mist or drizzle, but never a heavy rainfall. Okay. Now composed of thin layers of clouds covering a very large area. Then after that, nimbostratus. Nimbostratus basically appears like this. Nimbostratus is going to have drizzle is very light rain. You would have experienced drizzle sometime or the other in your life, where you have very small raindrops which keep on falling, where it is it if you walk out of it, walk out in the open during that point of time, you can feel very tiny droplets, but you don't immediately feel the urge to open up your umbrella, if you recall that memory from your life. So that very tiny steady raindrop, that is what is drizzle. Okay. Now, here, nimbostratus, they are particularly thick and they have a horizontal development. Now, within the nimbostratus itself, you can have the presence of, within it, you can have the presence of a cumulonimbus cloud also. So that will give different color pattern to the nimbostratus, where you observe certain areas are brighter, which means what? That light is able to push through them. That is why they appear brighter. Certain areas, they are very, very dark. And that is because there, for example, in this region, light may be able to penetrate through that. But here, the light won't be able to penetrate through this particular thick portion very easily. So this will appear brighter, this will appear darker. Now, in this nimbostratus, whenever you have these nimbostratus clouds, what kind of weather phenomena you expect is a continuous, steady rainfall. So many of the times you would have come across a scenario. Recently, rainy season has passed, so you would be able to associate with it. Many of the times you would have come across a scenario that it has started raining at 3 p.m., 4 p.m., and it is not raining very heavily. The rains which create a lot of noise. So it is not raining very heavily, but in a moderate manner, it continues to rain for multiple hours together, maybe till 9 p.m., 10 p.m. Right? So here in this case, you will find that prolonged, steady rains. Okay. So in this case, here, prolonged, steady rains. Okay. So rainfall is not going to be very heavy, and rainfall is going to be continuous for a long duration of time. So whenever you come across these kind of cloud formations, understand that it is going to rain for a long time, but it is never going to be very, very heavy for that matter. in brief patches, where let's suppose in these areas or in these areas, in brief patches it might be heavy, but over a continuous duration of multiple hours it will continue to shower some amount of rainfall. But then eventually we come to the most dangerous of them all, and that is the cumulonimbus. Cumulonimbus, these clouds are so very thick, they have a thickness of around 10 kilometers or more also. So that is why you will definitely, most of the times, you will come across different polarities of charges developed in different parts of this cloud. So this cloud is always associated with thunder and lightning. Okay, so they will always produce lightning and thunder. These are the clouds that you observe during the conditions of a hailstorm, during the condition of a cyclone, during the condition of a tornado. So in all these, you will come across this kind of a cloud type. Okay, and it is tallest among all the clouds. Cumulonimbus clouds span all the layers, extend right from 2 kilometers above the surface, and can extend for multiple layers. Generally observed during the summers and the afternoon of summers and spring months, when you have the earth releasing heat due to the process of convection, more condensation keeps on happening, and eventually the cloud grows on larger in size and vertical development happens. Now, there are further more details about the different types of clouds. As I told you yesterday, also, that you have warm clouds, cold clouds, you have the clouds where you have supercooled liquid water, you have the clouds where you have ice crystals which are there. Then, even when you talk about the cloud formation, then why there is a vertical development which happens even after reaching the saturation, why is it that condensation happens at different heights? But you don't have to go into those details. That is not required for your GS portion. For your GS portion, just try to recollect this particular area. Just try to consolidate this particular area and revise it multiple times. Once you are able to understand the pattern of naming, that high altitude clouds will have the name cirrus associated. So if they are formed in feathery, wispy appearance just like that, cirrus. If they appear in layers, cirrostratus. If they appear in accumulation, cirrocumulus. Mid altitude clouds, the word alto is used. So if they appear in layers, alto stratus. If they appear in accumulations, alto cumulus. Then you have the low level clouds, stratus, cumulus, and a combination of both, that is stratocumulus. And then eventually you have multi layered clouds also. So, for example, you have nimbostratus and the cumulonimbus cloud types. Okay, right? This is a spelling error. I hope this was understood, my dear friend, isn't it? Or did this create so much amount of doubt in your life? So spelling errors, you can be a little forgiving for the spelling errors, I think. Right. Otherwise, I'll also start becoming grammar Nazi when you ask the questions. So in that case, I do see the type of questions that you send. So, right. So, anyways, here now we come to the event of a cloudburst. What is a cloudburst? What do we understand by a cloudburst? So, when we talk about the event of a cloudburst, the image is here self descriptive. So, here you observe that suddenly there is a large amount of downpour. Everything which is contained in the cloud simply starts dropping by. So, this event is created when the cloud becomes so unsustainably large that it is unable to hold its weight any longer. And then suddenly it gives way. So, you have all the amount of ice crystals, liquid droplets, etc., all that is contained. All of them, they start falling at the same time. And that is what creates that event of cloudburst. So, in that small area, within a very short span of time, you will have very high amount of rainfall, which is observed. Very, very high amount of rainfall. So, just the heavy rainfall and just the event of a heavy rainfall is not categorized as a cloudburst. But here, it is a localized but intense rainfall activity where rainfall of 10 centimeter or more in an hour, 10 centimeter of rainfall in an hour, over a roughly 10 by 10 kilometer area is classified as a cloudburst event. Now, here you might not realize what this 10 centimeter of rainfall in an hour, how big that is. Just to give you an idea, do we have any idea about what is the average annual rainfall in India? Do we have a clue? Any of us? Very good. 1192 centimeter is basically once it was observed in Mosindram and Cherrapunji. That is the highest rainfall across the world. No. Okay. Okay. Just stop. Take a pause. Take a pause. Yes, Mita. Now you are correct. When you have removed centimeter and put millimeter, now you are correct. And Pratyevsha, that I hope you have pronounced your name correct. You are also correct. Ziba, you are perfectly correct. So average annual rainfall in India is around 100 to 120 centimeter per year. On an average, the entire country in 1 year receives around 100 to 120 centimeter of rainfall. So imagine if a small 10 by 10 kilometer area that receives 10 centimeter in 1 hour or more than that. Now, if this event continues even slightly more than 1 hour, you can imagine the consequences of that. It leads to sudden flooding of the rivers and creates flash flood events, right? So, and that causes disaster, which is unforeseen. Now it can, in the mountainous area, it triggers landslides almost immediately, because so much amount of rainfall immediately will start weakening the slope, and the slope starts, and the soil in that area, the rocks, they almost start moving like a fluid, and that is where the devastation is actually furthermore exaggerated. So cloudburst events are always associated with events of flash flood, landslides, and so on. For example, the Kedarnath disaster of 15th and 16th of June 2013. It has been almost 10 years. But rarely have we witnessed that kind of a disaster unfolding in front of our very own eyes. In that particular disaster, while the official figures, they are always, in a way, they are going to lie, but the unofficial figures, they are close to, or those of you belonging from that area, or those of you who sadly would have witnessed those events, you would have observed that close to around 25,000 to 30,000 people, they lost their lives during that cloudburst event. So that is how devastating the cloudburst can be. And when added on to administrative inefficiency, that is what leads to that kind of damage in terms of human lives that we see. Even today, if you open up the newspaper, you will come across some random stories every other month that some individual who was basically, lost during the Kedarnath disaster finally regained his or her memory, and they have now walked back home. So think about the magnitude of that disaster. You had to be there to witness it. You had to be there to observe that. So areas of Uttarakhand, areas of the region of Himachal, these are frequented by cloudburst events. And so is the region of northeastern hills and mountains also. So when we talk about cloudburst, why does it happen? It happens because the clouds will grow unusually large, unsustainably large over a very short period of time. So here you might have a question that if the clouds are unable to hold their own weight, if the ice crystals are unable to be held in that region anymore, then how did the clouds grow so large that eventually it came to that situation? Immediately, as it would have gotten heavier, immediately it should have rained. But that is not the case. So that is because of the conditions created. So let us understand that. So these cloud bursts, mostly in majority of the cases, occur across hilly and mountainous. areas majority of the time. And then sometimes, very rarely, in plain areas and plain regions also. So what happens? Here, understand this. When we talk about the mountainous area, when we talk about, let's suppose the mountainous area, here if suppose this is a mountain, now here as the winds they keep on coming, let's suppose during the monsoon months, you have the winds which have lot of moisture. During these monsoon months, the winds carry lot of moisture and they will bring rainfall. So these winds, they are a continuous phenomena. It is not as if a burst of wind has basically moved and then the next batch of wind will come after 1 month. No, it is a continuous phenomena. So as these winds they keep on moving, they are forced to rise up. Now, as they are forced to rise up, they will cool down. Whatever, they will reach saturation, and whatever vapor is present will start to condense. They will form this cloud, let's suppose. Now, in the meanwhile, more winds are coming. More winds are being supplied. They will also rise up. They will also undergo condensation. So the size of the cloud increases. Right. Then after some time, it is not the end of it, by the way. After some time, you will have more winds which are coming over, more winds which are being supplied, right? So they will also undergo condensation. So the cloud starts growing unsustainably larger in size. So you'll observe a very, very large and thick development of cloud happening, all the meanwhile ensuring much more condensation. Now, this cloud has already become very heavy and too big in order to hold itself. Had this been spread over a large area, the cloud would still have managed to accommodate it all. But all that condensation is happening in a concentrated area. So that is why it is becoming very, very heavy. But still, it doesn't fall. It won't bring you immediate rains. You know why? Because these winds, they are powerful enough to keep it aloft. These winds, they keep it aloft, and at the same time, more condensation keeps on happening, further increasing the size. Now, in this situation, it is like a disaster waiting to unfold. It is like a disaster that you know will happen when you observe this cloud. And then, let's suppose, for even a couple of hours, or 4 5 hours for that matter, or half a day or 1 day, if there is some distortion in this wind movement, let's suppose this wind movement becomes irregular or gets discontinued even for 1 day or a few hours. Now there is nothing to keep that cloud aloft. Now everything which is contained in a cloud will try to immediately fall down. And that is when eventually it will bring that entire moisture that it has contained in form of very, very heavy bouts of rainfall concentrated in a small area. So in the hilly regions, immediately it will trigger absolute large amount of devastation, flooding, landslide events. For example, even this year, in the month of July, in the region of Himachal Pradesh, you had multiple such events of cloudburst. So leads to heavy rains, flash floods, landslides, etc. Okay. Now, sometimes, rarely, this is also observed in plain areas, where in the plain areas, let's suppose over a plain region, if there is an active and a very intense low pressure which is formed in the plain area. Let's suppose there is a very intense low pressure. Now, in that case, the winds will be attracted here to this portion, and the winds will then start rising up, right? Because in that low pressure, the winds will also get heated up, they will also start rising up. If the low pressure is very intense, it will continue to attract more winds, bringing more moisture if possible, and they also rise up. There also, with the same phenomena, the cloud keeps on growing larger and larger in size. Eventually, a situation will come when, if let's suppose the winds get discontinuous, even for a brief moment of time, even for half a day or a few hours, there is an absolute calm condition, right? You would have heard about the very famous adage, the very famous saying, "Silence before a storm." So it is absolutely calm before that, and then when there is nothing eh, which is going to hold the cloud aloft anymore, everything starts falling down. So that is when you come across these kind of phenomena. As you can see in the image, all that rainfall is concentrated here, and it appears as if everything is going to be emptied in this region. That is why these events, they get over within a couple of hours. Within a couple of hours, majority of that moisture in the cloud will be taken away. After that, you will have regular rainfall. But understand, by this point of time, already the rivers have flooded, already the landslides have been initiated, and after that, even the normal amount of rainfall which occurs can further exaggerate these problems. Now, can we detect these cloudbursts? Can we predict these cloudbursts? We can. We have, the scientific advancements have been carried out in the world where these cloudbursts can be predicted. You have the modern day Doppler radar systems, which basically they understand, or they are able to detect not only the where the clouds are present, but also the thickness of the cloud, also the amount of moisture present in the cloud. So you know when a cloud is becoming unsustainably large, and you will be able to predict that in this region you can have a cloudburst. So we can always predict that. We have that prediction ability, but then in certain cases, due to administrative inefficiencies and so on, and also a kind of a vague warning issued by the meteorological department, this is not done, and that is what leads to disasters. For example, during the event of Kedarnath disaster, as that disaster unfolded, now Indian meteorological department and ISRO also, they became aware of that. ISRO, first of all, with the help of its satellites, they studied that, and they were able to understand that, and they were able to basically understand and predict that there can be a cloudburst in the region of the Himalayas, because in Uttarakhand, particularly in the districts around Pithoragarh, around the region of Uttarkashi, generally around the region of Kumaon, Garhwal Himalayas, you will experience a lot of these events. So ISRO people, they were able to understand, they were able to predict that a cloudburst is going to unfold here within the next 2 to 3 days. They alerted the Indian Meteorological Department. Indian Meteorological Department, they took their own particular good time, and they submitted a warning 1 day before that cloudburst, but that warning was not taken a look by any of the relevant authorities. And you will be actually pleasantly surprised to know about the reason, which actually, this is the reason that it is not something that I'm making up. It is the reason which was actually printed in all the national newspapers of that time. All the newspapers, they carried this, where the government officials, they actually had the wherewithal to come in front of the media and tell them that, look, this warning came to us after 5 p.m. and our offices were closed, so we could not, nobody was there in the office after 5 p.m. So what could we do with the warning? And then you had the weekend, so everybody was at home, and then it was during the weekend that the cloudburst happened, due to which 25,000 to 30,000 people died. Why? Because the warning was sent just a few hours back, and it was after 5 p.m. So that is the audacity of the administrative mismanagement, and the times that we live in. So that is basically how this cloudburst occurs. LP here refers to low pressure. LP here, this is your low pressure. Anjali, how many distance between cloudburst? Cloudburst is an event. Cloudburst is not a type of cloud, Anjali. Understand? It is an event. It is a phenomena, right? So that event, that phenomena is caused when the clouds, they become very unsustainably large. So the lower level of the cloud can be maybe 1 to 2 kilometers from the uh, ground surface here, but their vertical extent can be quite significant, right? It is not always fixed that only at this particular distance you will have this cloud. So cloudburst is not a cloud type, Anjali. Please get that very clear. The cirrus, cumulonimbus, etc., that we have studied, those are the type of clouds. This is an event. Okay, I hope that is understood. Low pressure does not attract clouds. Low pressure attracts winds. Winds always blow from a high to a low. So when the winds are in motion, they come towards that low pressure. Upon getting heated at the, why can the low pressure be created? Either due to thermal conditions or due to dynamic conditions. In either of the cases, you have the rising of the air. So as the winds come there, they will also be pushed to rise up, and then as they are rising up, they will lose their temperature, and then they will lead to formation of cloud. Cloudburst will always have thunder and lightning. Why not? Why does wind blow from high pressure area to low pressure area? Kindly look at the lectures of day before yesterday, where we have talked about the pressure gradient force and the excess of molecules, the deficit of molecules. You will understand that, Aditya. And what if the wind does not stop and continues? What, it will continue to grow, but eventually the wind will have to stop sometime or the other. It is not going to be the case that this significant low pressure is going to be an activated low pressure always. It will sometimes, you will have a condition where the winds will either become lighter or will abate, and in that condition cloudburst can be initiated. Okay. And satellites can, like Meghna and Nisar, can also help to predict. Yes. Can we identify the clouds, which one is heavy, without any technology? From the ground surface, you can have a gauge about how thick the cloud is, but not about how heavy. Can we draw a diagram which when causes and management of cloudburst unpredictable disaster, question asked? Absolutely yes. Why not? How to mitigate this? You cannot mitigate the cloudburst. This is a natural phenomena which will happen. You can mitigate the loss caused during the cloudburst by having adequate early warnings and then evacuation plans in place. Shreyas, for artificial rains, they use nimbostratus mostly. Mostly they use sometimes even cumulus. Clouds are seeded with various particles to cause artificial rain. Uh, Desert areas have very high low pressure, so can they predict cloudburst? No. Because in desert areas, the winds will not have moisture, will they? So that is why it is, and it is not always the case that the desert areas will have very active low pressure. In fact, majority of the deserts that you see, they are desert because there is a continuous presence of high pressure in that region. High pressure means the air is sinking down, so no cloud formation in those areas. Okay. Cloudbursts can be in equatorial areas, not so much. Not so much. Because in equatorial areas, you have occurrence of everyday evening rainfall. Can we have artificial cloudbursts? No, very difficult to cause. Shubhankar, the ways to escape out of it, when you have the early warning which is received, you move out of that area. Can thickness of clouds be measured by the sonar? So the Doppler radar system uses that technique. The normal radar uses that sonar method. But when we talk about the Doppler radar, it basically uses the multiple of these methodologies of emission of sound waves to understand what amount of moisture is present. Okay. Now, after this, we come to the event which all of you have been waiting for significantly impatiently, and that is hailstorm. So, what is a hailstorm? And how is this hailstorm created? So, here, when we talk about hailstorm, what is it? Now, many of you have experienced over your life, obviously, depending upon the number of questions, based upon the number of questions that flooded the session in the last half an hour yesterday. I'm sure almost all of you have experienced that sometimes during the afternoons, along with heavy rains, you have chunks of ice which fall upon the ground surface, where there is a misnomer, where people think that it is basically snowfall, but it is not snowfall. It is what is referred to as a hail or a hailstorm. Now, these ice chunks which fall, which are particularly large in size, these are what are referred to as hailstones. Now, you would have observed this to be generally occurring during the summers and the summer season, and also sometimes during the early part of the rainy season. That is when you observe this, right? And that too during the late afternoons, or late during the night. You will not observe these hailstorm events to be prominent, let's suppose at 11 a.m., 12 p.m., or 1 p.m. No. Generally around 4, 5 p.m., or 4 to 6 p.m., or if not in that case, then during the night. So, this is the specific kind of disturbance which is created due to very active and very intense, mostly thermal low pressure, which is created on the ground surface. Okay. But for that hailstorm to occur, you need to have certain prerequisite conditions to be fulfilled. You cannot have hailstorms occurring anywhere and everywhere. So, here you need a couple of conditions to be fulfilled. So, all those people who could not get a night's sleep because snowfall was confused with hailstorm, this is your moment of glory. So here we talk about presence of thick cumulonimbus clouds, then also presence of very intense low pressure, mostly thermal low pressure, on ground, creating a strong vertical movement of wind. That is also what is referred to as updraft. So when you have very strong vertical updraft or movement of the wind in that region. Hailstorms occur with rain sometimes, yes. Why much more big size hailstones fall down, cause damage at that area? Okay, fair enough. So here, these conditions need to be fulfilled. Now, how is it that you have these large chunks of ice which fall down from the clouds along with rains? It is never going to be the case that only these hailstones are falling and no drop of rainfall. You will have these hailstones falling along with rains, right? So all those of you, the Einsteins and the Newtons amongst us, who were basically confusing hailstones with snowfall, at least you can apply that logic, that if some part can freeze, why is it that we are experiencing rainfall, and that too in the month of June or May or July? Why do we experience snowfall? Unless and until you have submitted to the fact that it is the nature of the almighty being to bring us this kind of an event, so let's not question. If you have that kind of a thing, then fair enough. But otherwise, if you question about it, that why this happens, think about it, that when this happens, afternoons, during the summers, now that is a high temperature condition. Now in that condition, why will the ice fall or the snowfall happen, if you are thinking about it that way? So here, understand the property, understand the entire process also. So you have very thick clouds, which are a prerequisite for this. Very, very thick and dense cloud. So generally, obviously, you can have only one type of a cloud which can lead to that event, and that is basically the cumulonimbus, which can be very thick, having a very strong vertical development. Now, let's suppose this is your ground surface. Now, near the ground surface, if you have a very intense low pressure, or let's do one thing, let's draw this in the next slide so that it is less confusing. So you have very dense and very thick cloud formation, having a very strong vertical development in a cumulonimbus cloud. And then you have this as the ground surface, let's suppose. Near the ground surface, you have a very intense low pressure, mostly thermal low pressure. Now, this is the reason why we experience this in the afternoon, is because of the fact that throughout the day, the heating of the land would have happened. And as the heating of the land would have happened, this low pressure would have further intensified. It would have gotten very, very strong. So around this low pressure, you would basically have winds which are going to come. And the winds will obviously also get heated up. As they get heated up, where will the winds go? They will rise up. They will rise up. And these winds, they will be moving significantly with a strong force, with a strong velocity upwards, right? That is why during the event of a hailstorm, you would have observed that there is a very strong wind motion. That is not always the case with the other kind of rains. But with the case of a hailstorm, always there will be very, very strong wind motion. Now, let us understand this. So, we do know that in these clouds, you have the presence of various ice crystals, ice particles. So let's suppose an ice crystal from here, it has started to fall down because it has become heavier, slightly heavier. So it has started to fall down. It is falling down, the cloud. Now, as it encounters this strong wind, the wind which is very, very strong, so that wind will again reforce that particular ice crystal to go back up. Because the wind is so very strong, it won't allow the ice crystal to fall down. It will send it back up. So this ice crystal, directed by the wind, again starts to rise up. Again, it starts to rise up. But as it rises up, even if it would have melted by the time that it is coming into the portion beneath the cloud, again it will start refreezing. It will refreeze. When it refreezes, it will accumulate more moisture and more water vapor around it. So its size continues to grow larger. Size continues to get larger. Eventually, it will reach the level till which the wind is able to send it. Depending upon the power of wind, that is how much distance it will travel. But after reaching maybe wherever the wind has sent it, again, this ice crystal is heavier. This is very heavy. So this will start dropping again. So this ice crystal will start dropping again. And in the meanwhile, as it is dropping, it will continue to accumulate other ice crystals around it, liquid water droplets around it, and it will continue to grow bigger and bigger in size. It will continue to grow bigger and bigger in size. Now, as it comes down, it melts, partially melts. But then again, the wind is so very strong, the wind will send it back up. And the wind, this time when it sends it back up, again there will be refreezing. All those will refreeze along with the particles nearby. And it will continue to grow bigger, much bigger in size. It grows multiple times bigger in size. Eventually, you come across a scenario where the size becomes so unsustainably large of that ice particle. It becomes so unsustainably large that the force of gravity is overwhelming. Okay, this becomes large, and you have this large ice crystal or large ice particle which starts falling. As it starts to fall, this time because the size is so large, even the wind movement won't be able to uphold it, won't be able to send it up anymore. And that is where it will partially melt on the outside, but its size is so large, it will fall on the ground as these large ice crystals. This has got nothing to do with cold ground surface temperature or low temperature on the ground surface, etc. No, this is created purely because of that multiple vertical movement of these ice crystals, where they continue to keep growing larger in size, and eventually they will grow so very large that the winds won't be able to throw them up anymore, and they will fall as hailstones. So this is what is a hailstone. So this is created due to multiple vertical movements of the ice crystal or the ice particles. The ice particles melt while coming down, melt and are rethrown upwards, where they refreeze. Repetition of this event leads to very large ice particles, ice chunks, which then fall on the ground as hail. Okay, so that is how you have the events of hailstorms which get created. Okay, for that you need very intense low pressure on the ground surface, generally observed during the summer, or sometimes even the dynamic low pressure can facilitate that. But along with that, you have very, very thick cloud cover, where you can have these multiple trips of the ice crystal being facilitated, where every time it will refreeze, it will keep on growing in the size. Okay, This means that hailstorms are common during cloudburst? No, my dear friend, no. Absolutely not. Please understand, in the case of the cloudburst, in the plain areas, when we talk about the cloudburst, it is the winds which vertical winds which has led to the condensation of the cloud and which has basically kept the cloud afloat. Not necessarily will you have the portions starting to fall during that development of a large cloud during a cloudburst, right? And in these hailstorms, need not have the clouds to be unsustainably large. Even a normal thick cumulonimbus cloud can facilitate that. Okay. Reason why it is not always only in summer. Sometimes even during the winters you observe that when you have that low pressure created in certain cases in certain areas, there also you can have that. So it is not only restricted in summer, but then low pressure is very important, and generally during afternoon, because during the afternoon is when you would have facilitated that heating, and that is when the intense low pressure, which is essential, has been created. Okay. Now this is the question, the pre-YQ, that you can deal with this. So here, when you take a look at this question, which of the following statements is correct? Cirrus clouds are composed of ice crystals. Cirrus clouds have a flat base and appear as rising domes. Cumulus clouds are white and thin and form delicate patches and give a fibrous and feathery appearance. Cumulus clouds are classified as high-level clouds. Think about it, read the statements carefully. Good. A majority of you have given the incorrect answer. So, let us first of all analyze the incorrect answer that majority of you have given. Majority of you have given the answer as C. Cumulus clouds are white and thin and form delicate patches and give a fibrous and feathery appearance. Now, just to show how much attention you are paying in the class, when we talk about it, they are feathery wispy formations. Which are those? These are cirrus clouds. Cumulus clouds, they are puffy and have a vertical development, heaped up cotton, right? Now, if I bring you back to the statement of the question, cumulus clouds are white and thin and form fibrous and feathery appearance. Which cloud will give that appearance? Is it going to be cumulus? No, it will be cirrus. This is incorrect. It will be cirrus cloud which gives that. Then after that, cirrus clouds have a flat base and appear as rising domes. So which cloud has got a kind of a flat base and appear as rising dome-like structures? Which cloud has this kind of a characteristic? Perfect. It is the stratocumulus. So this is also incorrect. Cumulus clouds are classified as high clouds. Cumulus stratus and stratocumulus, they are classified as low-level clouds. Cirrus clouds are composed of ice crystals. This should be a very easy deduction. Where is it that you find problem in these kind of questions? Normally the brain runs so quickly, and when you have these questions, cirrus clouds are obviously high altitude clouds. Yes. Right. So every cloud has ice crystal, fair enough. But does that make this statement incorrect? What is the question? Which of the statements is correct? Is the question that why a particular statement is correct, or why can a particular statement not be correct? Out of all these, if three are incorrect, one is correct, and in this, let's suppose I would have put a statement that altocumulus clouds are formed by condensation. Would that statement be incorrect because all the clouds are formed by condensation? So will that be statement be incorrect? No, that is also formed by condensation. Okay. Now, after this, we come to the types of rainfall. So rains, when we experience rainfall in any particular portion, now that rainfall basically occurs because of one reason or the other. So, based upon the reason why rainfall is being observed or is being experienced in an area, based upon that, you have the classification in the types of rainfall. So, when we talk about the types of rainfall, this is classified as convectional rainfall, orographic or relief rainfall, and also the cyclonic or frontal rainfall. Now, fronts is something that we will study in the next module, but basically, convectional rainfall. Here, due to the process of evaporation, rising up of air, when you have from the normal area, from a normal ground surface, the air starts rising up because of getting heated. So then it will condense to form various different cloud types, mostly cumulonimbus, and it will bring rains. That is the convectional rain. Orographic, well, let's suppose a wind is basically approaching a hill or a mountain. It is forced to rise up, it is forced to get uplifted, and that is when it will cool down, attain saturation, condense, form clouds, and bring rains. That is orographic. Then you have fronts or cyclonic rainfall, which we'll talk about. So, here, when we talk about convectional rainfall is basically observe where you have the rise of air parcel due to heating, and that air parcel eventually condenses after attaining a certain height where it would cool down, right? So wherever you have significant amount of evaporation happening on a daily basis, there you will find this convectional rainfall to be a common phenomena. So this is associated with a rising air parcel due to the process of convection, associated with, in fact, all the rainfall or all the cloud formation will happen only when the air parcel is rising. None of the regions will experience rainfall in the condition of sinking air. Always when the air is rising, only then the cloud formation will be observed. Why? Because when the air is actually rising up, in that case only will the air begin to lose temperature. It will begin to cool down. It can attain saturation and form the cloud formation associated with evaporation and convection, vertical rise due to convection. So generally, in the regions of the marine areas, right, where you have an ocean or a sea, so islands in the marine areas, they will experience this. Marine areas themselves will experience this. Equatorial regions, they will experience it on a daily basis, where by during the daytime, during the afternoon time, when there is very high temperature, everything will get supremely heated up. There will be a lot of rising air parcel because of that heat, so everything will evaporate. After reaching a particular height, things will start to cool down, the air will start to cool down, reach saturation, and lead to condensation. Now, slowly and steadily, as more amount of evaporation keeps on happening, it leads to the formation of cumulonimbus clouds as well. So that is what it leads to. So here, eventually, observed in tropical island regions, okay, by the way, I received a very weird mail yesterday which got me thinking about how much we are aware of. Are we aware where Iceland is? Do we know the location of Iceland, or do we know what Iceland is? I had a mail from a student who asked me the question that please provide the differences between an island and Iceland. You have not taught about the difference between an island and an Iceland. So that is basically what got me thinking. Are we aware that Iceland is a different region and islands basically they are a geographical entity? Iceland is also kind of an island like structure, or do anyone of else we share that doubt? We don't share that doubt. Well, even if you share that doubt, I don't think now you will raise it up. But I hope we are aware about this. If you have any of these kind of doubts, please don't be afraid to open up the atlas. Trust me when I say so. When you open up the atlas, the world is not going to end. It is not going to lead to a disaster. So try doing that. It is not the worst thing that you will do in your life, right? So open up the atlas, try to see where the various different countries are. If this at this particular age in your life, if you are not aware about the various different countries of the world, think about it yourself. Are you suitable enough to sit at that position of a bureaucrat, of a decision maker in Indian foreign services? If let's suppose you get selected, and you start getting confused that okay, Iceland they have said, but I think Andaman Nicobar islands were there where this Iceland is coming. So it is high time in your life where for your general awareness you should be aware about the countries of the world, right? The various different countries in the world. Okay, and please don't have that expectation as you were taught in class 5th or 6th, where that is the good result that we are seeing about the teaching methodology in our school days or in our school times. So basically, you should not have that expectation that I will stand in the class and I'll tell you, friends, this is France. Next to France, what you see is Germany. Next to Germany, what you see is basically Switzerland. There you have Poland. Write Poland in your paper. Then next to it, you have Russia. Write Russia. So I hope you don't have that kind of an expectation setting. I hope we are mature enough to understand how to. But today, anyways, I am so very much shaken up by that mail yesterday. Today, I will take up that. I'll give you that assignment for the map pointing. Okay, and please do mark it on the map. I will tell you how to operate the map atlas also. Even though it is a book, it is a simple book, but many of us are so very afraid of the atlas that if I open it up, maybe a kraken will emerge out of it, or maybe an animal will emerge out of it and they will bite us all. So today I'll tell you that atlas is absolutely harmless. It has got no particular hazardous material inside it, so don't be afraid to open up the atlas. Okay, so here when we talk about this convectional rainfall observed in tropical island regions and equatorial areas on a daily basis in the evening. Generally, you will observe around 4 p.m., 5 p.m. on a daily basis, there is going to be occurrence of rainfall. Now, this rainfall is associated with thunder and lightning also, because you will have the vertical development of the cloud type, you will have the development of the cumulonimbus cloud in this. So that is why it is always associated with thunder and lightning. Always associated with thunder and lightning. Okay, so it occurs because of the vertical motion of the air, where the air, after getting heated up, might rise up along with all the evaporated water vapor, and that is what will lead to the cloud formation. Now, Then after that, you have orographic. Now remember when we were studying about the portion of geomorphology, I understand right now it might appear as if something you have done in your past life or in your past birth. That is how long back we studied geomorphology, but we studied it recently. Remember, we studied something about orogenic force. So basically, epirogenic, orogenic, anything to do with the mountains. That is where the term orography, orogeny is used. So when we talk about orographic rainfall, this kind of rainfall is created when the moist winds, the rain bearing winds, when they face an obstruction in the form of a physical barrier. Now, when they face that obstruction in the form of a physical barrier, the winds are forced to rise up. And as they rise up, they cool down, they attain saturation, and they condense thereafter. So, here, observed when moist winds face a physical barrier, when they face that physical barrier, be it in the form of a mountain, a hill, an escarpment. For example, Western Ghats is an escarpment, but that also offers a barrier. So when they face that physical barrier, in that event, rise of winds, cloud formation, and eventual rainfall. So these rains are going to be orographic rains. Now, here we have observed this multiple times. We have seen this multiple times now, ever since we have seen about the portion of Chinook, Phone, etc. But here the logic is very simple. The side of the mountain facing the wind, that is referred to as the windward side. This is your windward side. The side of the mountain opposing to it, that is what is referred to as the leeward side. Now, as the winds they approach the windward side, they are immediately pushed up, they are immediately lifted up, where they lose the temperature and they undergo condensation. As they undergo condensation, there will be cloud formation in this area. Yes, like the western part of Western Ghats, right? Correct. So here, or the southern face of the Himalayas, there also. They will lead to this cloud formation, which will normally bring rains in this area. Right. So the windward side will always end up receiving rains. Always. Now, the wind or the air which then emerges thereafter, that is going to be dry because all the moisture has actually been condensed in the form of cloud and has brought rainfall. So this wind will be dry. Now, as it is dry and then it starts coming down, it will heat up as well. Due to adiabatic compression, this will get warm also. You have warm and dry because of adiabatic compression and dry. Now here, in this area, on the leeward side, you'll find that this region is devoid of rainfall. So this is the region which is devoid of the rainfall, and that is where this is the region which is referred to as the rain shadow zone. This is the region which is known as the rain shadow zone. Okay, because there is not much rainfall occurring in this area. So again, I will tell you, when you have winds coming towards the mountain, these winds, when they face the mountain, they will have to be forced to rise up. There is no other alternative to that. They will be forced to rise up. So as they are forced to rise up, they do rise up. And then eventually, as they are rising up, they will become cooler and cooler. And eventually, they will lose so much amount of temperature that they will start condensing. whatever water vapor was present in that wind, it will undergo condensation. Now, as it undergoes condensation, so there will be cloud formation. So the air will have only some amount of water vapor. It is not as if as the air is moving, somebody is injecting water vapor along the way. The air, whatever amount of water vapor it is carrying, that will be it. Right. So as the air is coming in, as the wind is coming in carrying that moisture, as it rises across the windward side, all that moisture will start to condense to form the clouds. And this cloud will be observed, this rainfall will be observed in this portion. And this is your windward side. So windward side will receive rainfall. But the wind which has emerged after this on the other side, that will be dry, right? Because all the moisture has already been consumed. So if the wind is dry, will they be able to cause rainfall? No. Why? Because how is rainfall created? The water vapor, unless and until it undergoes condensation, will there be rainfall at all? No. So here this wind has become dry in nature. This has become dry. So obviously, it will not have the ability to bring that substantial amount of rainfall at all. Plus, to add on to that, as this wind is sinking, it is coming to an area where the air density is very high. So the air has to compress itself. Remember the fundamental that we studied in the case of Chinook and phone. So here the wind has to compress itself. So that is where, due to adiabatic compression and adiabatic heating, this wind becomes warm also. So you have the warm winds and the dry winds on the other side. And these warm and dry winds, basically, they won't be able to cause any rainfall. That is why the leeward side is generally very dry. Now, if you talk about the region of the Western Ghats, you will observe that the western side of the Western Ghats receives very heavy amount of rainfall, whereas talk about the eastern side of the Western Ghats, they are very dry, very, very dry. Now, I understand when I take so much of east and west, if you can get confused between island and Iceland, so there is no limitation to it. But let's simplify it furthermore. So here you have the Western Ghats. This is the Indian subcontinent. The diagram is of the Indian subcontinent. I won't be labeling it. I hope that you will be able to understand this. This is your region of Western Ghats. Okay, this is just a diagrammatic representation of the Western Ghats. I understand that in reality, Western Ghats might look different, but this is a kind of a diagrammatic representation. So here, as you have moist winds coming from the region of Arabian Sea. Now, Western Ghats, it is like an escarpment. So the shape of it is very much like a vertical wall, and then some amount of that plateau-like structure, and then you have this kind of a phenomena. So here, immediately these winds are almost pushed up vertically. That is why in this area to the west of Western Ghats, you have very heavy intensity of rainfall. Very, very heavy intensity of rainfall. But on the other side of Western Ghats, it is dry. Be it the eastern part of Maharashtra, be it Telangana, be it Karnataka, and even be it the northwestern part of Tamil Nadu. Even Andhra Pradesh, some parts for that matter, they are dry. There is an exception, however. Exception where? In the region of Nashik, Pune, Bangalore. These are exceptions. Even though they lie on the eastern side of the Western Ghats, Nashik, Pune, and Bangalore, even though they lie on the eastern side, they are much cooler in comparison to their surrounding areas and they receive high amount of rainfall. And that is purely because in Western Ghats, you have certain gaps. You have certain gaps which are available. And through those gaps, the winds are able to pass through. The moist winds are able to pass through. And that is why they bring that rainfall. Otherwise, this is the characteristic or the nature of orographic rainfall. The reason why Meghalaya experiences amongst the highest rainfall across the world is because of the orographic rainfall. When we come to Indian monsoon and Indian climate, I will show you the map there also. But you would basically observe there that in the region of northeastern area, you have the mountains creating a kind of a funnel shape. So any moist winds which get into there, they basically they hit one mountain after another, after that another mountain, after that another mountain. So they have to drop all the moisture that they contain. So that is why the region of northeastern part of the country receives such high amount of rainfall. Which are these gaps? These are the Thal Ghat, Bor Ghat gaps which are present in the western ghats. And then after this, you have the frontal and or the cyclonic rainfall. So I'll not go into the detail of the cyclonic rainfall as of now. You will understand it automatically after the next module. And same is the case with the frontal rainfall. But just to again repeat that concept of front when we studied the frontal inversion, fronts are zones of transition where air masses of different properties they confront each other. You have cold air on one side, warm air on the other side. So that is what is a front. So when we talk about a front, these are zone of transition between air masses of different temperature, density, vapor, etc. So you have various different types of fronts also we'll study very shortly. But when we talk about this front, you have a cold air and then you have an overwhelmingly large volume of warm air. And cold air is pretty much compressed and condensed in terms of its volume. So cold air has got a very restricted volume, warm air has got a significantly larger volume. Now here, as the warm air basically starts to move, let's suppose, the warm air as it starts to move, eventually this warm air will start rising up, this cold air. Right. Why? Because it is not going to be the case that warm air starts moving, it starts pushing the cold air away. It will straight away, the cold air having such a compressed volume and having such a compact structure, it will start acting as an inclined plane where the warm air straight away starts rising up. So the warm air starts rising up. So now the warm air would have reached a region like this. Right? This would be the region of the warm air, suppose. Now in this area here, the warm air gets in contact with the cold air. So the temperature will drop. For that warm air, the temperature will drop. It might reach saturation. After saturation, condensation will happen. Cloud formation will happen. So here, the clouds will be spread over in this entire zone of contact. And that is where rainfall will be observed. This is what is known as a frontal rainfall. In this region, as you can observe, there's also a frontal inversion in place. The different type of temperature inversion that we have studied, there's a frontal inversion also in place here. So that is how you have the creation or the existence of a frontal or a cyclonic rainfall. So again, we will study this immediately in the next module, but fronts are basically the zone of transition where you have the warm air and the cold air confronting each other. Now, when you will have the warm air which starts rising up, the cold air, now that is when the warm air gets in contact with the cold air, loses temperature, becomes colder. When the air loses temperature, it reaches saturation after a point of time. If it cools down beyond that, there will be condensation, cloud formation, and it will bring rainfall. Frontal rainfall is generally not experienced in India. Generally, frontal rainfall is experienced in the mid latitude and slightly higher latitude areas. in the region of Europe, northern part of Asia, region of North America. That is where frontal rainfall is a very common factor. Okay. Now, after this, we come to the formation and the occurrence of fog. Now, the definition of fog, basically everywhere it tells you it is a cloud formed near the ground surface. But the simplest of it is fog is formed when you have condensation happening near the ground surface. That is what leads to the formation of fog. Okay. Condensation happening near the ground surface. Remember, we have always talked about the fact that condensation can never happen without any platform. A platform is a must. A platform is a must for that condensation to happen. A condensation will never happen without a surface. Now, near the ground surface, where does the condensation happen? So, around the dust particles. So, around the various different dust particles which are contained, that is where this condensation happens. So, here, let's suppose this is the ground surface. And here you have various different smaller dust particles. Dust particles, the density is always highest closer to the ground surface. The concentration of dust particles is always going to be highest closer to the ground surface. Right. Now, if by some reason or the other, the air near the ground surface becomes so very cold, for some reason or the other, if the air becomes very cold, loses temperature, reaches saturation, cools down beyond that, that is when the condensation starts happening around these nuclei, around these dust particle nuclei, which are also referred to as the hygroscopic nuclei. Around that condensation process will start happening. And these are very small particles of liquid water droplets which are created. And that is able to suspend itself in the air. And that is what we regard as fog. Mist is also formed in the same way. But here, if someone asks you why fog is created, simplest of the answer will be because the air near the ground surface cools down beyond the point of saturation. There's a cooling down which has to happen by some reason or the other, due to different conditions, in different areas, in different scenarios. But the crux of it will always be the fact that the air near the ground surface has to cool down so very rapidly, has to lose temperature so very rapidly, it reaches the point of saturation, cools down beyond that, and then you have that condensation. Now, based upon why that condensation happens, based upon that fact that why the air loses its temperature so quickly, you have the classification of fog. You have surface fog, advection fog, valley fog, upslope fog, steam fog. All these classifications of fog that you have is purely and simply because of the fact that air, due to some reason or the other, near the ground surface becomes very, very cold. Now, now let us take a look at the confusing definition. Fog is a cloud with its base at or very near to the ground surface, or a cloud that touches the ground. It shows up when water vapor or water in its gaseous form condenses near the ground surface. Now here, mist, as I told you, is also a very similar phenomena. Here also condensation will happen near the ground surface. The only difference between a fog and the mist is the size of that droplets formed after condensation. That is the only major difference. So when we talk about mist, so the only difference between mist and fog is that mist contains more moisture as compared to the fog. In mist, each nuclei is larger. They contain a thicker layer of moisture. So when that event is observed, we refer to it as a mist. Okay. Otherwise, it is known as fog. Now, fog also has various different classifications, types of fog, and this classification is done based upon why and how the condensation happens, and that is because of the why and how of air losing the temperature. So, classification on the basis of why and how the process loses temperature and condenses. So on that basis, you have the classification. So can we finish these and then take a break? Are we fine with that? Can we finish this classification and then take a break, and then we'll move on to the next module after the break? Good. So we'll take a break after we complete this, right? Okay, fair enough. So we have different types of fog: radiation fog, advection fog, upslope fog, steam fog, and valley fog. In all of this, there is one common factor. And that common factor is that the air near the ground surface will lose the temperature and will undergo condensation. In all of this, that is the common factor linking all of this. So, some reason or the other, air will cool down. So, starting with the radiation fog. When we talk about radiation fog, this is caused when the Earth's surface loses heat so very quickly. How does the Earth's surface lose heat? By releasing that terrestrial radiation. Remember the long wave terrestrial radiation that we talked about? So, the Earth's surface loses heat because of that terrestrial radiation. Now, eventually, the Earth's surface, when it cools down very significantly, it will cool down the air above it also. The air immediately above it will start cooling down very rapidly because now the ground surface has cooled down. So, when the air starts cooling down, it will reach saturation. And if it cools down furthermore, it will obtain condensation. But this condensation has happened why? Because the surface has been losing heat continuously by terrestrial radiation. If that terrestrial radiation would have been stopped, re-radiated back by the clouds, etc., no fog formation would have taken place. The only reason fog formation has taken place in this case is because the surface is losing that heat by terrestrial radiation. That is radiation fog. Advection. I will give you the written and the details in the PPT also, don't worry. Advection. What is advection? Horizontal movement of wind. That is advection. So imagine a scenario where you have the condition of a warm advection, in the sense where you have warm winds coming into the region where you have cold temperatures on the ground. So as this warm wind comes over, it will basically cool down by getting in contact with the cold ground surface. So as that warm wind cools down, what will happen? It will reach saturation, it will cool down beyond that, and it will lead to fog formation, right? Similarly, you have upslope, where the wind, as it starts moving up the mountain slope at a slow speed, there itself, temperature will start dropping, and across the slope itself, you will find the formation of fog. So let us take a look at each one of them in slightly greater detail, starting with the radiation fog. So when we talk about the radiation fog, the why of it. Why? First of all. So the why of it is very simple. You have basically ground loses heat by terrestrial radiation. Those of you who remember the portion of surface inversion, You would recall that almost the phenomena is similar. Loses heat by terrestrial radiation, then air in contact with the ground also cools very rapidly, undergoes condensation. So, this is the kind of fog that you are observing in the various parts of the country as of now. So, as we move ahead into the next month of December as well, January also, various parts of the country you will experience that fog. It is this fog which is created. So, it appears late during the night, early in the morning is when it will start dissipating. So, as the ground surface, let's suppose the ground surface loses heat very quickly, very rapidly, cools down very quickly. The air above it will also cool down. The air above it will also cool down. So, as the air above it will also cool down, there will be condensation in the entire area here. And that will be covered under a thick layer of fog. Now, it will continue to remain in this position until next morning. Next morning, when the sun rises up again, the sun will start heating up the ground surface. And then the ground surface will start heating up the air from below. And that is when the fog will start dissipating. So that is why this fog, generally you would observe that late at night, early in the morning, the region is covered with fog. But after around 7 a.m. onwards, when the sun starts becoming very visible and very palpable, that is when the fog starts disappearing near the ground. Slightly above, you will still find the formation and the existence of fog. Eventually, it starts thinning out from bottom upwards. Right? So, that is a common phenomenon and a common feature of it. Fog dissipates from bottom upwards. Now, for achieving or attaining this kind of a fog formation, what are the conditions required? Conditions required for this. Yes, a few days, in few cases, it remains there for the whole day. That is when you will observe that the sun is not shining through. You have so much amount of cloud cover, etc. So the sun has not got an opportunity to shine and heat the Earth's surface. That is when it will persist for around 11 a.m., 12 p.m., sometimes also. Okay, but in general, again, around 1, 2 p.m., it disappears, and again, it starts reappearing after 7 p.m., 8 p.m. when the air cools down. Right. So here the conditions required are long winter nights so that the surface can lose heat easily. Then after that, basically clear sky, because the clouds, they will re-radiate that heat, the terrestrial radiation, and they will reheat the ground surface. So that is why clear sky, calm conditions, that is lack of wind movement. Wind movement. Why? Because if there is a strong wind movement, whatever condensates are getting created, they will be carried away and blown away by the wind. That is why it is under these conditions that a radiation fog is generally observed. Okay. Now, advection, a very simple process where basically you have, let's suppose, a wind getting moving and coming in contact with a cold surface. It will create fog. right? Sometimes this is the reason why even during the in the coastal areas you will find the formation of fog, as you have winds moving over the sea. If the sea is cold or colder in nature, it will lead to condensation happening there, right? So this kind of fog is what is known as advection, because it is created due to the movement of wind. Here the warm wind, it moves as into the colder area, the example of warm advection. So as the warm wind enters into the colder area, it gets in contact with the cold surface, and that is when it actually carries out that process of condensation. Okay, now then you have steam fog. Steam fog is actually quite unique. Steam fog is basically what is not understood in this. See, please, I don't know if it works in other subjects for you guys or not. I'm not sure about that. But if you simply write one worded statements here, not understood, repeat, etc., so kindly be kind enough and kindly try to elaborate it. After all, you have to write the examination, understand that. So not understood, advection fog. Okay, now that is better. So advection fog is, what is the process of advection? Are we aware about that, Uni? Or are we not sure what is advection? If you are not sure about what is advection, I will redirect you to module 6 again. If you are sure about advection, then we proceed ahead. So advection is what? Advection is the horizontal movement of wind. Advection can be warm advection, cold advection. Advection, when we say warm advection, that is when warm winds move into the region of the colder air. The image is self-descriptive here, but nonetheless, when we have a cold surface or a cold area, let's suppose you have warm winds which are moving here. Warm winds. These winds get in contact with the cold area, so the wind will lose the temperature, will cool down. After what? After getting in contact with what? With the cold surface. Cold surface. Right? After getting in contact with the cold surface, the wind will cool down. What happens when the wind cools down? It reaches saturation. Right? If it cools down beyond that, what happens? Condensation. So how will that condensation happen? In the form of fog formation. Is that understood? Yes, good. Now, after this, we move to the steam fog. What is a steam fog? So when we talk about steam fog, it is a very unique phenomena which gives you an appearance as if steam is rising up from the water, which is not the case generally, but it gives you that appearance, at least, that steam is rising from water. Now, why this is created and where and when is it observed? So this is observed above water bodies, generally early in the morning, right? Generally early in the morning, you have this being observed over the water bodies. Generally observed over water bodies late at night and early morning. So why do they get created? So basically, okay, just after this, I'll take a break. Don't worry. Don't start panicking. Immediately after this, I'll take a break. Don't worry. So here, let's suppose you have a water body. You have a water body like a large reservoir, a large, for that matter, riverine movement, sea, or something like that. Now here you have, let's suppose, the land area. In this area, this is your land, this is your water. Now during late at night or early in the morning, which will be warmer, water or land? What do you think will be warmer? Late at night and early in the morning, which will be warmer, water or land? Good. Water. Perfect. Water will be warmer. Land will be colder because the land has managed to lose heat much quickly. Right. So, water body being slightly warmer, there will be evaporation which will happen, isn't it? And evaporation can happen. Even at night, evaporation happens. Early morning also evaporation happens. So, let's suppose you have the particles which are evaporating. Particles which are undergoing evaporation. Meanwhile, from the regions of the land, you have cold air which starts moving over to the water because water is comparatively warmer. So, comparative low pressure, land is colder, a comparative high pressure. Winds always blow from a high pressure to a low pressure. So, here you will have cold winds which moves over. Now, this cold wind basically encounters this particular evaporate or the particles which are undergoing evaporation. So suppose evaporation is what? Evaporates are what? These are water vapor particles. So water vapor particles, when they suddenly get in contact with the cold wind, what will happen? Those particles will start condensing. Wherever they are, they will start condensing. So they start condensing as they come in contact. There is condensation happening. Okay. And this condensation will appear as rising structure, and that is why it gives you an appearance as if it is like a steam, but that is not the case. It is simply your water droplets or the water vapor which condenses after getting in contact with that very cold wind, right? So it is the cold winds getting in contact coming in contact with the evaporated vapor, leading to condensation. Here also, condensation will happen across the dust particles only. The presence of various dust particles, they will be utilized for the condensation here also. Right, many of the times over these seas, etc., you have small salt particles which are basically emanated by the sea during the sea waves. When the sea wave crashes closer to the surface, many of the small sprays are emanated, which consist of these sea salts. So that is also serving as the platform for this condensation to happen. So here, leading to condensation happening late at night or early morning, especially during the winter months. And it appears as if it is rising. That is why it gives you an appearance of that of a steam fall. With that, before we eventually break down, let me take a break. And then after that, we will cover the remaining portions and then we will pursue with the portion of cyclones and fronts also. So we take a break. Can we do with a break of 10 minutes today? right? 15. Okay, today is the last day I'm giving a 15 minutes break, by the way, just to make you aware. This is the last day I'm giving the 15 minutes break. After that, we will start with the 10 minutes break from next week. So let's take a break and let's be back in 15 minutes and we'll continue. A confirmation about the audio? Yes, Aditya, this was the last 15-minute break that you got. After that, no 15 minutes break. Good. So, we had basically seen the three different types of fog, that is radiation fog, advection fog, as well as steam fog. Now we take a look at upslope fog. So when we say upslope fog, that is when across the slope of a mountain or a hill, where the slope is not very steep, the slope is slightly gentle, when you have a slow movement of air, that is when slowly and steadily the air starts losing temperature, condensation starts to happen, right? If the wind movement is very strong, then as they hit the slope, they will be lifted upwards to form the clouds. So that is why here generally the wind's movement is considered to be slow. And it is that slow movement that creates that upslope fog, right? So here, when we say an upslope fog or a hill fog, that forms when the winds blow up across the slope. So then the winds lose temperature. This is also what is an orographic uplift. So the winds lose temperature and form, undergo condensation. This is the reason why many of the times early in the morning, if you go to the mountainous areas or the hilly regions, early in the morning, the top of the hills, etc., is not visible, right? Because of that upslope fog. So that is basically this upslope fog. Then you have the valley fog also. Now, what is this valley fog? Valley fog generally is created late at night, from late evenings itself, and late at night, and it is formed almost till early in the morning, right? So here, the formation and the property is very similar to what you have observed to be present in the case of valley inversion. The property and the formation is very similar. So let's suppose here we consider a mountain. Between the mountains, let's suppose we consider the valley portion, right? Now here you will have the presence of cold winds. Cold winds will be present here. Now, these cold winds, now as compared to the winds on top, here on the valley, you will have warm winds. Warm air in general will be present here. Right, you will have warmer air. Now, these cold winds, they start to sink. They start to sink. They continue to sink. As they continue to sink, they will replace the warm air. Not only that, but the warm air here gets in contact with the cold mountain wind which is coming down the slope. So the warm air of the valley gets in contact with the cold wind coming down the mountain. Right, coming down the mountain. And that is when the warm air loses temperature and undergoes condensation. That is when this undergoes condensation. That is when you will find the presence and the formation of this valley fog like structure. That is how the valley fog gets created. Okay, so generally, when this entire region is fogged up, you have fog formation in the entirety of the area. The valley and the valley bottom is not at all visible, never is visible, right? And this oftentimes leads to very significant amount of disasters also, very major disasters. For example, uh, as I would have mentioned earlier also, I think you had the very unfortunate disaster in December 2021, if I recall correctly, where we lost our first Chief of Defense Staff, General Bipin Rawat. Now, that was due to a helicopter crash, if you recall. Now, that helicopter crash happened in the hills around Kannur, right, in the region of the southern hills. Now, why is it that that crash happened when you had so very trained pilots of the Air Force having such remarkable years of experience behind them? Still, that crash happened. Why? Because oftentimes, when you're flying between these areas, that is when the fog is present randomly in certain pockets because of that valley feature. And that immediately removes your visibility perspective. You have no clue about what is the depth of that area, what is or where you have an obstruction thereby. So that is when oftentimes the helicopters and the choppers they crash with the side of the mountain, and it leads to that unfortunate event. Similarly, in Arunachal Pradesh also, you experience these frequent crashes. One of those unfortunate ones led to, again, the sad demise of one of the chief ministers there. So that also was because of that valley fog. So oftentimes that valley fog can be very disastrous. Helicopter has lights. Yes, my dear friend, helicopter has lights, which simply tells me that you have no clue about how thick the fog gets. If ever you try to, let's suppose, even in the case of radiation fog, you try to drive through the region of Delhi NCR, right? Through the Yamuna Expressway, put all the lights that you have, get the addition halogen lights that you can, all of them, and put it on. And still you will have vehicles piling up on each other. Why? Can everybody be at fault at the same time? No, the visibility is reduced. And when you are talking about choppers, helicopters, they are moving at a very high speed also. So the reaction time is particularly less. Yes, the sad demise of Rajshekhar Reddy was also one of those events, which basically is created or was created due to this. Is there no device installed in helicopters to detect the thickness of any obstruction? They have a terrain mapping system. They have a terrain mapping system which will give you the idea of the terrain. So oftentimes the choppers they fly between these valleys, or even if they go up, let's suppose they are taking a turn, that is where they have to come down ever so slightly. And suddenly, if there is a mountain in front of them, there is hardly any time in which they can react. Because it is not the case that, like a video game, that okay, I'll put this arrow up, now my helicopter will go vertically up. So that is not how it operates. So that is why you have these crashes which happen, right? Black box is a different thing altogether. Yes, Aditya, it is dangerous. So that is basically about the type of fogs. Now let us take the prelims questions which have been asked from the areas that we have covered till now. So few of the questions we'll take now, few of the questions we'll take later. So, what causes the wind to deflect to the left in the southern hemisphere? This should be easy. Let's try to have at least 80 to 90% of the correct answer in this case. What causes the wind to deflect to the left in the southern hemisphere? Yes, Kuraku, that is correct. 65% of you have given the correct answer. So the correct answer in this case is C, rotation of the earth. So what causes the wind to deflect to the left? It is the Coriolis force. And this Coriolis force is experienced. Why? It is due to rotation of planet on its axis. Okay? Then, after this, westerlies in the southern hemisphere are stronger and more persistent than the westerlies in the northern hemisphere. Why? Southern hemisphere has less landmass as compared to the northern hemisphere. Coriolis force is higher in the southern hemisphere as compared to the northern hemisphere. Again, read the question statement very carefully. Westerlies in the southern hemisphere are stronger and persistent. Why? So this should be again easy. Sagarika, I'm new and this is my first class. So Sagarika, see, because it is your first class, always expected that many of the concepts might not be easily comprehended by you, might not be easily understood by you. Please do not panic. Please do not think that how will I cover this. So what you can do moving ahead is either you can look at the recordings, the previous sessions and the recordings of that. That will help you. And there I would suggest to you that look at the in order to follow the sessions, you have 3 days holidays coming up. That is Saturday, Sunday, and Monday will also be a holiday. So you have 3 days holidays coming up. So revise the portion from this week, only this week. That is from the portion of climatology. Revise that in these 3 days from the recorded videos. And from Tuesday onwards, there is no reason why you shouldn't be able to follow it. Okay. And Monday is a holiday, by the way, guys. So here, good. Majority of you have given the correct answer, but in a good number of you have given the wrong answer as well. So why is that the westerlies are more stronger in the northern hemisphere? That is because westerlies are more stronger in the southern hemisphere. Because in the southern hemisphere, you have less landmass, you have very less landmass which is there, and you have a predominance of water bodies in the southern hemisphere. Now, because of that predominance of water bodies, there is less frictional force, less force of resistance, and that is why the winds gain that speed. So here, the first statement is going to be correct. What about the second statement? Coriolis force is higher in the southern hemisphere. Coriolis force, first of all, will be equal in both the hemispheres. And secondly, that can never be the reason why the winds will be stronger. If the winds are stronger, might be the Coriolis effect is more. But it will never be the case that why, due to Coriolis force, the winds will become stronger. So second is absolutely incorrect. So the correct answer in this case will be A, 1 only. Now, again, one of the questions where I want you to answer what is asked in the question, not what you know in life. Okay. A layer in the atmosphere called the ionosphere facilitates radio communication. Why? The presence of ozone causes the reflection of radio waves to Earth. Radio waves have a very long wavelength. Which of the statements is or are correct? Chandrajyoti, fair enough. The what you are saying that due to less friction, the wind velocity will be high and hence the Coriolis effect will be high. So understand that is high Coriolis effect is an effect, impact, not the cause. Cause is high wind speed. What was the question? Why there is high wind speed? So high wind speed, that answer can never be that what high wind speed leads to, right? Why there is that high wind speed? So that high wind speed is because of less frictional force. Okay, I hope that is understood. Now, here, majority of you have given the incorrect answer. So very proud of you guys. So here, understand why I had told you answer what is asked in the question. So what is asked in the question? A layer in the atmosphere called the ionosphere facilitates radio communication. Why? So why is it that ionosphere facilitates radio communication? Because you have the presence of charged particles. Due to presence of charged particles or ions. Had these ions not been present, would the ionosphere be able to reflect the radio waves? Regardless of whether the radio waves have a long wavelength, short wavelength, intermediate wavelength. If these ions would not have been present, would the radio waves have been reflected back? Absolutely not. So the only reason why the radio waves are being reflected are because of the presence of these ions. Now let us take a look at the statement. The presence of ozone causes the reflection of radio waves to Earth. No. Ozone is present where? In the stratosphere. Ionosphere is much higher above than that. Then, radio waves have a very long wavelength. Fair enough. Radio waves have a long wavelength. But if there would not have been the presence of ions there, would these long wavelength radio waves be reflected back? If, let's suppose, the ions are not there, then why isn't that the radio waves are reflected from mesosphere itself? Why isn't that the radio waves are reflected from the ozonosphere itself? Why only ionosphere? The reason is the presence of ions and nothing else. So that is basically incorrect. So that is where the correct answer is going to be D. Okay? I hope that makes sense. Now, jet aircraft fly very smoothly in the lower stratosphere. What could be the appropriate explanation? There are no clouds of water vapor in the lower stratosphere. There are no vertical winds in the lower stratosphere. Now, this statement framing was a bit dicey this year by UPSC, but then we'll take up the answer that UPSC has given for this. Karthik, correct. Sagarika, your logic is correct, but then the answer given by UPSC is different. Shalu, correct. So marginally, majority of you have given, 38% of you have given the correct answer. Again, very proud of you guys, how you are able to recall everything that we have discussed till now. But the good thing to know is that the correct answer, majority of you have given between B and C. So I won't blame you guys in this. Because here, what UPSC had given is that there are no clouds or water vapor in the lower stratosphere. That is something which has been marked as correct. Right? So there are no clouds of water vapor in the lower stratosphere. That is why there is no turbulence in that. However, whenever you come across these statements, always be on the lookout for the absolute terms. That no cloud whatsoever, but in the lower, all the climatic actions, all the portions of cloud cover, etc., that will be found in troposphere. There are no vertical winds in the lower stratosphere, correct? Why? Because there you have a negative lapse rate due to negative lapse rate. So this is also correct. So the correct answer in this case will be C, both 1 and 2. Okay. Now, after this, we basically move ahead and we come to the next set of module. Just a moment. So there is the leaderboard. This is the leaderboard. Okay. Now we come to the next module. Before that, let me take a couple of minutes, 5 minutes of break, and let me sort this out, and we'll be back in a couple of minutes. Okay. Okay, guys, basically, apologies for this. There has been some issue with the PPTs, it appears. So, there will be a new link which will be sent to you. Kindly join the classes from that link, and we are going to send a new link to you as soon as possible within a couple of minutes. Join the classes from that link, okay? And then you can basically carry forward. I hope it is not much of an inconvenience. So, we will be sending a new link to you. Please do join the classes from that new link, and we will be starting the discussion for air masses and cyclones. That is an important topic. So, do join. Okay? The link will be sent. Fair enough. Just a moment.